Today we're going to be looking at multiplying and dividing rational numbers. This is a review, so you should be familiar with this material. Starting by looking at our rules for integers with multiplying and dividing. For two positive numbers would give us a positive number when we're multiplying or dividing. If we are multiplying or dividing two negative numbers, we would also get a positive number. If we are multiplying a positive and a negative, or dividing a positive by a negative, we would get a negative answer. And if we are multiplying a negative times a positive, or dividing a negative by a positive, we would get a negative answer. So if you are adding or multiplying two numbers that are positive or multiplying two numbers that are negative, you're always going to get a positive answer. And if they're different, if one's positive and negative or one's negative and positive, you'll get a negative answer. Looking at multiplying integers, two numbers with the same signs. You multiply the numbers, and the sign is going to be positive. So if you look above where we multiplied two positives, we got a positive answer. And we multiplied two negatives, we got a positive answer. So 5 times 2 gives you 10. And a negative 7 times a negative 3 would give you a positive 21. So if they have the same sign, you get a positive answer. If you have two numbers that you are multiplying and they have a different sign, you still multiply the numbers, but the sign is now going to be negative. So a negative 8 times 5 would give me a negative 40, because we had one negative and one positive. And then 11 times a negative 6 would give you a negative 66. And that's with multiplying integers. If we look at dividing integers, same rules apply. Two numbers with the same sign, you divide the numbers because we're dividing, and the sign is going to be positive. So 10 divided by 2 is going to give you a positive 5 because we had two positive numbers. And a negative 15 divided by a negative 5 is going to give you a positive 3 because two negatives divided give you a positive. Two numbers with different signs, we're still going to divide those numbers because we're dividing. But the sign now will be negative because we have one positive and one negative. So if we take a negative 20 divided by 5, I get a negative 4. And if I have 30 divided by a negative 6, I get a negative 5. Next couple questions you can do on your own to see if you understand the rules. And then we'll look on the back. So on the back now we're going to start to look at fractions. What do we do when we're multiplying fractions? Last class we looked at adding and subtracting. Today we're going to look at multiplying and dividing. While multiplying fractions, we just multiply those numerators and then multiply the denominators and then reduce if necessary. In last class we had to do a lot of reducing when we were adding and subtracting, so you should be quite comfortable with reducing. So multiplying our numerators, those are the top numbers that are on top. So I'm going to take 2 times 4, and that gives me 8. Then I'm going to do 3 times 3, and that gives me 9. And then I stop and I think, is there any number that would go into both 8 and 9 that I can reduce this by? And there's not, because the only thing that goes into both of those is 1, and if you divide it by 1, that will not reduce that. Second example here is still multiplying. Remember, if we have something in parentheses next to another number, that's multiplying. So we're going to multiply our numerators. 4 times 1 is 4. And then we'll multiply our denominators. 5 times 4 is 20. Now, is there a number that could go into both 4 and 20? Well, there is. A lot of you will say 2, so I can divide both of them by 2. And then I have 2 over 10. Now I don't stop. I check again. Is there something that will go into both 2 and 10? And there is. I could have divided these both by 2. And then that would give me 1/5. When I get 1/5, there's nothing that will go into both 1 and 5. You could have also, some of you may have done this, you had 4 and 20. You may have said, hey, 4 can go into both of those. And that gives me 1/5 also. Doesn't matter which way you do it, you just make sure you reduce it so you can't reduce it any further. The last way it was just a little bit shorter, a few steps, but that's not a matter which method you use. Mixed numbers. Mixed numbers changes to improper fractions. And then do what we just did. Multiply your numerators, multiply your denominators. So looking at this first example, changing 2 1/3 to an improper, which we did last class. Remember, it's 2 times 3 plus the 1. So 2 times 3 is 6 plus 1 is 7. So this will be 7/3 times, well, 1 2/3, to change that to improper, we take 1 times 3 plus 2. So 1 times 3 is 3, plus 2 is 5, so 5/3. Then we multiply straight across. 7 times 5 is 35. And then 3 times 3 is 9. And we stop to think, is there any number that will go into both 35 and 9? Well, the only numbers that go into 9 are 3 and 9. 3 does not go into 35, and 9 does not go into 35, so we are done. We do not have to write it as a mixed number. We can leave it as improper. The second example, we have one mixed number, so we have to change that one. So 5/6 is fine. We can leave it as 5/6. Times, instead of 3 and 1/6, we're going to change that to an improper fraction. 3 times 6 is 18, plus 1 is 19/6. Then we're going to multiply straight across. We're going to do 19 times 5, and some of us may want to pull out a calculator for that. 19 times 5 is 95 over 6 times 6 is 36. Now we start looking at, are there any numbers that go into both? And I like to start with the smallest number. So I think about 36, and I think, what numbers go into 36? Well, 2 goes into 36, but does 2 go into 95? No. 3 goes into 36, but does 3 go into 95? No. And again, you can be checking this with a calculator. 4 goes into 96, but does 4 go into 95? No. 6 goes into 36, but does 6 go into 95? No. 9 goes into 36, but does that go into 95? No. 12 goes into 36, but does that go into 95? No. And then 36 goes into 36, but does that go into 95? It does not, so we are actually reduced. We are reduced there. Now, dividing fractions. What do we do when we divide? Well, we change our division to multiplication using KISS. Keep it, switch, switch, which you've probably seen already. We keep that first fraction the same. We switch the division to a multiplication. we switch the second fraction to its reciprocal or its inverse. In the past, some of my students have called this reciprocal. You're flipping it. And then you reduce if necessary. So looking at this example, 2/3, that's the key. Keep it as 2/3. The division, I'm changing to multiplication. And then my second fraction, I'm going to flip it, give the reciprocal. So instead of 4/3, it'll be 3/4. And I'm going to follow the rules for multiplication. I'm going to multiply straight across my numerators. 2 times 3 is 6. Multiply straight across my denominators. 3 times 4 is 12. And I think about, are there any numbers that can go into both 6 and 12? And 6 goes into both of those. So I get 1.5. Could have also, or may have also noticed 3 went into both, or 2 that went into both. But then you would have to do 2 reducings. Second example, 4/5. That stays the same. Keep it. So I'm keeping 4/5 as 4/5. Changing my division to multiplication, because keep it, switch, and then switching 1/4 to its reciprocal, which is 4/1. Then I'm going to multiply straight across. So 4 times 4 is 16. And then 5 times 1. 5 times 1 is 5. And then I think about it again. Can I reduce it? What numbers go into 5? 5 and 1. Does 5 go into 16? No. So that is reduced. Now what happens when we have mixed numbers? Well, mixed numbers, we're going to follow the same thing we did with multiplying. We're going to change mixed numbers to improper fractions. And then because this is division, we'll have to remember to do our keep it, switch, switch. So first step is to change those mixed numbers into improper fractions. 2 times 3 plus 1 is 7. 7/3. These are the same fractions we actually had in the multiplying section. And then 1 and 2/3 would be 1 times 3, which is 3 plus 2. And that ends up being 5/3. Now, because it's a division problem, we're going to follow the rules for division. Keep the first one the same, 7/3. Change division to multiplication. Change 5/3 to its reciprocal, which is 3/5. Now we can just multiply. Multiply straight across. 7 times 3 is 21. 3 times 5 is 15. Think about what numbers go into 15. 3 goes into 15, and guess what? 3 goes into 21. So I'm going to divide those both by 3. And I end up getting 7/5. And there's nothing that goes into both 5 and 7, so I'm done. Second example. We have 5/6. Divided by. I would still say divided by, even though I know I need to change that to multiplication because I want to change that mixed number first. So 3 and 1/6 is going to be 3 times 6, which is 18 plus 1, so 19/6. Now I'm going to take care of keep it, switch, switch. Keep that first fraction, 5/6. Switch the division to multiplication. Flip the last fraction, so instead of being 19/6, it'll be 6/19. Now it's just a good multiplication problem. 3 times 6 is 30. And then 6 times 19, and again you may need to pull out a calculator for that, but 6 times 19 is 114. Now I have to think about, can I reduce that? What goes into both of those? 2 could go into both of them. 3 or 6 actually will go into both. I'm going divide them both by 6. And again, if you don't see the 6, you just see the 2, you do the 2. And then later on, you'll have to reduce again with 3. So you just, if you see the one number, you know, or it takes twice, that's fine. So it ends up being 5/19. Now we have to put it all together. Because you not only have to be able to multiply, divide fractions, but you also have to be able to multiply and divide fractions when they are positive and negatives. So looking at this first example, 7/8 times, I'm going to make that -2/1. Because 7/8 is a fraction, I want to make the other number a fraction too. -2 is going to be -2/1. Remember, all numbers can be written as a fraction. And so then I can just multiply straight across. 7 times a -2 would be a -14. Because remember, a positive times a negative gives you a negative answer. And then 8 times 1 is 8. Now I have to think about, is there something that will go into both of those? And for sure there is, because they're both even. So I can divide them both by 2. And that gives me -7/4. And that cannot be reduced. Second example, write -5/1 divided by 2/3. You know, I have to change division to multiplication, so -5/1 times 3/2. Because remember, you switch the division and then you flip that second fraction. And now I can multiply straight across. Negative times a positive is going to be a negative. -5 times 3 is a -15. And then I'm going to multiply my denominators. 1 times 2 is 2. And then I think about, is there anything that will go into 2 and 15? Well, 2 goes into 2. And 2 does not go into 15. So there's my answer. And then this last one is a multiplication. But I do have a mixed number, so I need to change 4 1/2 to an improper fraction. 4 times 2 is 8, plus 1 is 9, so that's 9/2 times 2/7. Now, because it's multiplication, I don't need to do the keep it, switch, switch. So 9/2, I can just multiply straight across. 9 times 2 gives me 18. And then I can multiply the denominators. 2 times 7 gives me 40. Now they're both even, so I know I can divide it by 2. And when I divide by 2, 18 divided by 2 is 9. 14 divided by 2 is 7. Now you can try the u-dos and see how you